Work out the following integral. The integral of 3x minus 2 over x plus 3, x squared plus 2. Now this might be something new for a lot of you, but this can actually also be split into partial fractions. What we've got here is a linear factor and a quadratic factor. So that the linear is a over x plus 3. Now for the quadratic factor you must try bx plus c over x squared plus 2, because here we have a quadratic factor. So this is perhaps the new bit. You can see this will work if you once we've got the answer. If we went back, we would get this. So that gives me 3x minus 2 must be equal to a times x plus 2 plus bx plus c in brackets times x minus 3. That will make this denominator the same as this denominator. Right, so the tactic here, we look at this one, we'll make that 0 minus 3. So that means that bit's 0. We put minus 3 in here, we're going to get minus 11. And if we put minus 3 in here, we're going to get 11 and times a. That gives that a is minus 1. The next step is to let x equal to 0. The reason for letting x equal to 0 is this becomes 0. And this becomes 0. And then when you do c times 0, you get 0 as well. So we're going to get minus 2 is equal to 2a plus 3c. So any term with x in will be 0. Look, so when you expand this, you get bx squared plus 3bx plus cx. All those terms will be equal to 0 if you let x equal to 0. And you're just left with the constant term, which is 3 times c. We've already got a, so we'll put it in here. So we get minus 2 is equal to 2 times minus 1 plus 3c. So we get minus 2 is equal to minus 2 plus 3c, which means that c would have to be equal to 0 for that to be true. So now equating coefficients of x squared. Well, there is no x squared term on this side, so that's 0. Here we get ax squared, and here we're going to get bx squared. We've already got the value of a, so we've got 0 is equal to minus 1 plus b, therefore b is equal to 1. Right, putting these values back into this, possibly swapping these two over because a is negative. So we got the integral of 3x minus 2 times 3x over x squared plus 2 is equal to x plus 2 is 1x, so I'm just going to write that as x squared, minus 1 over x plus 3. Right, if we differentiate ln of x squared plus 2, we get 2x over x squared plus 2, but I don't want 2x plus 2, I want 1x, so I'm going to have to put a half in front of that. So it's a half of ln of x squared plus 2. This one's straightforward. This was just going to be minus ln of x minus 3 plus c. Right, the half can go up here. So it's ln of x squared plus 2 to the half minus ln of x plus 3 plus c. When you subtract, you can do a division. I'm going to make the half square root of x squared plus 2 over x plus 3. I do now need to put the absolute value because the denominator here could be negative. Also, don't forget the plus c. So this has been a video to show you how to integrate a function where the denominator has a linear factor and a quadratic factor. I hope you've understood, and I thank you very much for watching.